Hello, today I'll be explaining what convex milling is. Starting with an introduction to milling itself. Milling is a common manufacturing process where rotatory cutters are used to remove material from a piece. This process allows us to create parts with accurate dimensions and good surface finishes. Milling is used in a wide range of applications, from basic tasks like flattening a surface to more complex operations such as cutting gears and making slots. It's a key process in machine parts and tools. Conventional milling versus convex milling. In this slide, let's talk about the difference between conventional milling and convex milling. Conventional milling is very useful when we need to machine flat surfaces, but when it comes to making curved or round surfaces, it does not work well. That's where convex milling comes in. Convex milling uses special contouring techniques to handle curves. This often requires expensive machines like CNCs. However, in places where such machines aren't available, like small workshops or schools, manual method for doing convex milling can be very helpful. Problem statement. Here, we discuss the problem we are trying to solve. CNC machines are very good at making complex shapes, but they're also very expensive. Not every workshop or educational lab can afford them. There's a clear need for cheaper and manual way to achieve similar result, especially for curved surfaces. This project was created to fill that need. It introduces a mechanical setup that imitates CNC styling milling, but it is much cheaper and works manually. Project objective. The main goal of this project is to create a low-cost milling setup that can perform milling on convex surfaces. This setup should be simple to use, not dependent on electricity for motion, and must be able to produce accurate results just like more expensive machines. The objective is to make milling education and production more accessible even in low-resource environment. Platform mechanism. In this part, we learn about the physical setup of the milling system. The platform where the workpiece is placed has a curved shape and is held between two inclined rods. This platform can move along the curved path with the help of a lid screw, which is turned manually. A drilling machine stays fixed in position as the platform moves under it. Milling is done along the curved surface. This motion copies what a CNC machine would do automatically. Working principle. This slide explains how the machine works step by step. First, we fix the workpiece under the curved platform. Then a person manually turns a crank, which rotates the lead screw. As the lead screw turns, the platform moves smoothly in a curved path. While this happens, the milling tool, which is actually a stationary drill bit, cuts into the material following the curve. This way, we can mill a convex shape without using CNC machine. 3D model. This slide shows a 3D model for the entire setup. It helps visualize how all the components come together. You can see the curved platform, the guiding rods, the lead screw mechanism, and the fixed drill machine. The 3D view makes it easier to understand the arrangement and function of each part before actually building the real system. Mechanical components. Now let's understand the mechanical parts used in this system. There's a curved platform that moves in a controlled arc to copy the milling control contour. A lid screw and nuts are used to move the platform forward or backward. The inclined support rods guides the movement along the curve. Everything is held together in a strong frame which keeps the system steady during the milling operation. Design model. This slide presents the design version of the setup. It may be a CAD model or a drawing that shows exactly how the parts fit together. It helps to double check the design before making the actual prototype. At this stage, adjustments can be made to improve the function or simplify the assembly. Supporting elements. In any mechanical system, we need supporting components to ensure smooth working. Here, bearings are used to reduce friction in moving parts. Fasteners like nuts and bolts are used to connect everything securely. There are also mounting plates to hold the drill machine and platform in place. Finally, there is a hand crank that the user turns to operate the system manually. Assembly and fabrication. This slide explains how the system is built. All the parts are made from standard materials like mild steel, which is strong and easy to work with. The components are joined using welding or pulls. The design is simple enough so that it can be assembled, disassembled, or repaired easily. This makes it perfect for classrooms or small workshops where the machine might need to be reused for different purposes. Develop prototype model. Here we see the final prototype that was built based on the design. It shows the working version of the system and proves that the concept works. This prototype is useful for demonstrating the process of convex milling in a real and practical way, especially in educational environment. Application. This system has many useful applications. It's perfect for schools and colleges where students can learn about counter milling without using expensive CNCs. It can also be used in small factories for making one or two items at a time. Even in rural or low budget workshop, this machine can be used to work on curved surfaces, which is usually hard to do without advanced tools. Conclusion. To sum up, this project offers a smart and low-cost solution for convex milling. It helps students in small workshops perform convex milling operation without needing high-end machines. By using simple mechanical parts and manual input, it becomes more affordable and educational tool for everyone involved in manufacturing or mechanical engineering. Thank you for your attention. I hope you have